Today we will do the question from 3.6 to 3.18. Question 3.6 is, in the button cells widely used in watches and other devices, the following reaction takes place. Zinc solid plus Ag₂O solid plus 2H2O liquid to give Zn2 plus aqueous plus 2Ag solid plus 2OH negative aqueous. We have to determine the delta G naught and E naught for the reaction. Actually, this question is in NCERT, but these values are not given. But when question comes in board exam or any other exam, these values should be given to you. Zinc to zinc 2 plus 2 electron, E naught oxidation, or sometime E naught reduction. Ag₂O solid plus H2O plus 2 electron to 2 Ag plus 2 OH negative, E naught reduction, that is 0.344. It should be given to you. Now let us solve it. First tell me, E naught, how do we calculate E naught cell for the given reaction? What is the formula to calculate E naught cell? Yes, beta. E naught cell is equal to E naught cathode minus E naught anode. These E naught are reduction potentials. Reduction potential of cathode minus reduction potential of anode. Now E naught cathode. What is cathode? This one, Ag₂O to Ag, that is cathode. And what is anode? Zn2 plus 2 Zn. These are the reduction potential values. See, E naught oxidation is this one. So what is E naught reduction? That is this cell, Zn2 plus 2 Zn. So value is minus 0.76 volt. Just put the value 0.344 minus 0.76. That is E naught cell is equal to 0.344 plus 0.76. So what is the value? 0.76 plus 0.344. That is 1.104 volt. Once again, I repeat, E naught cell is, what is E naught cell? E naught reduction of cathode minus E naught reduction of anode. Okay, and if at cathode reduction takes place, that's why it's positive value. At anode oxidation takes place, that's why it is minus E naught reduction. Otherwise you can write it as E naught reduction of cathode plus E naught oxidation of anode. This is the way to calculate E naught cell. This is the formula to calculate E naught cell. E naught reduction at cathode minus E naught reduction of anode. Or if E naught oxidation is given at anode, then you can write E naught reduction of cathode plus E naught oxidation of anode. Okay, so this is the answer of this question, that E naught for the reaction. Now delta G naught. What is the formula to calculate delta G naught? Yes, beta. Delta G naught is equal to, what is delta G naught? Standard Gibbs energy. Standard Gibbs free energy. And what is the formula for it? Yes, beta. Delta G naught equal to, yes, okay, I said E naught cell. Understood? E naught cell equal to E naught reduction minus E naught reduction of cathode and anode. Means E naught cathode minus E naught anode means standard reduction potential of cathode minus standard reduction potential of anode. But if standard reduction potential of cathode and standard oxidation potential of anode is given, then what we do? We add them, because at cathode reduction takes place and at anode oxidation takes place. Okay, this is the way. Okay, got it? Yes, beta. Okay, now next part is delta G naught. So delta G naught is related to E naught cell, and the relation is, yes beta, what is the relation? What is the relation between E naught and delta G naught? Delta G naught equal to minus NF E naught cell. Minus NF E naught cell. This is the relation. Delta G naught and E naught cell. They are related like this. What is the N? Number of electrons transferred. Now see, in this case, number of electron transferred is, say, zinc 2 plus. How many electrons are involved? 2. Ag₂O 2 Ag. Electrons involved are 2. That means N for this particular reaction is 2. Number of electrons gained or lost. You can write it as number of electrons gained or lost. So N for this particular reaction is 2. Okay. And F is Faraday. And this Faraday is charge on 1 mole of electrons. Charge on 1 mole of electrons. So charge on 1 mole of electrons equal to approximately, very good, 96500 coulomb. Now next part is E naught cell. So E naught cell is equal to, just we have calculated, it is 1.104 volt. 1.104 volt. Okay. Now delta G naught, it is equal to minus 2 into 96500 coulomb and 1.104. It is coulomb per mole, you know, and 1.104 volt. So coulomb volt is joule. So result comes in joule. So value is 2 into 96500 into 1.104. That is 213072. 213072 joule. Or in kilojoule, it is 213.072 kilojoule. This is the value. 96500 into 2 into 1.104. So this is the value in kilojoule, or to write in scientific notation, it is 2.13072 into 10 raised to power 5 joule. That's it. So this is the question number 3.6 of NCERT exercise of electrochemistry.